We are looking at even and odd functions today. So let's start with our even functions. Even functions are symmetric to the y-axis. So in this image I have here, this graph I have here, here's the y-axis, and you can see that this parabola that we have is kind of cut in half or mirrored along the y-axis. You could fold your paper along that axis, and those two parts of the graph will lie on top of each other. So you can kind of think about that y-axis cutting this graph in half. But there's also another way to look at this if you want to look at actual points. And so here again is our x-axis and y-axis. This is our origin right here, okay? And what this says is for every even function, there exists an xy, so a point. If it says for every xy, there exists a point negative xy, okay? So what we want to do is look at any point. Let's look at this point. This one's xy. And if we wanted to actually write this point out and name this point, this would be the point 2, 1. And this is saying if this is even, there exists a point negative 2, 1. So let's check that. Negative 2, 1. That is also on this parabola. So that is telling me this is an even function, okay? So again, we're focusing mostly on the y-axis, or you can pick a point and then check to see that the x value is changed sign and that point is also on the graph, okay? Now, for odd functions, you can do this really easily, I think, on paper. So like if you have the function on the paper, if you turn your paper 180 degrees or upside down, okay? So like the top becomes the bottom becomes the top, that graph is going to look exactly the same if it's odd, okay? Another way to describe this is that it's symmetric to the origin. Origin is right here in this one. And then lastly, if we wanted to look at a point, then you can say for every point xy, there is a point negative x, negative y. So basically you're changing the sign for both the x and the y value. So we can check that with this one. Here's a point here. This is the point 2, 2. We need to check to see if the point negative 2 is on there. So negative 2 is on this graph. And so that tells us it's symmetric to the origin. And if it's symmetric to the origin, it is an odd function. And these two O's match up, so that's easy to remember. Origin, odd. And then y-axis is even. Now, I'm not covering symmetric to the x-axis. That is a thing, but there's no name for that because if it's symmetric to the x-axis, it's not even a function because it will not pass the vertical line test. So just remember that, okay? And that's kind of what I'm saying right here. Any graph that is not symmetric to the y-axis or the origin, even if it's symmetric to the x-axis, that is considered neither. So basically, if it's not odd and it's not even, it's neither, okay? So let's look at some of these examples and determine which one is even, odd, or neither. So looking at our first one, what I would do is check both of these two cases. So looking at the y-axis, if I draw a line down through the y-axis, am I mirroring each side of the graph? Did I cut that graph in half? Do I have the left side basically reflecting the right side? In this case, yes. So again, symmetric to the y-axis is even. If you were not sure about that, then you can pick any point on this graph. Let's say we pick this one. Obviously, we want to pick good points, points that, you know, are whole number points. So this one is the point 1, 2. We want to see if there's, again, we're changing the x value. So we want to see if there's the point negative 1, 2. So let's check that. Negative 1, 2. That is also on there. And so this is even, and you just kind of showed that. So one other thing. If you have a point here, you should be able to go straight across and find the other point in the same, like literally horizontally, but the same distance here should be the same distance here, okay? Because that's going to give you that negative x value. All right, let's look at our next one. The next one, here's our y-axis. If I draw a line down through here, does my right side reflect the left side or vice versa? Does this cut it in half? Well, it may be cutting it in half, but it's not showing symmetry. So if I have this right side, the left side should look like this if it was even. Also, if I pick a point, let's just say, this is not pretty, but let's say that point right there, okay? Do I have another point going across here? No, I don't, okay? So it's definitely not even. Let's check out odd. Odd is if I have this graph, let's see if I can kind of emulate this. If I have this graph and I turn it upside down, does it have the same shape still? And it does. It does. So that's what you're looking for. Like if you were to draw this on your paper, turning it upside down should look the same. So if it looks the same, that is odd. But we can also do one other check. This is, let's just say point, I don't really know, 1, 2, 3, 4, 5. So let's say 0.8 and 1.4 or 5. Let's say 1.5. Do I have negative 0.8? Negative 0.8 if it's odd. Remember, both are changing. Negative 0.8 and negative 1.5. Yes. Okay. Another way to think about this is the distance from here to the origin. That angle, direction, and distance should be the same if you were to go through the other side. Okay, so this, if you go through the origin, you're going to have another point because that's your both changing, are changing both the x and the y to negative values. So if you're in the first quadrant, you're going to end up in the third. And vice versa, if you're in the second quadrant, like let's say here, you would end up over here. Okay, let me erase some of this since that's kind of messy. All right, next one. Let's check the y-axis. So go find your origin. Here's the origin. The y-axis is here. Well, clearly we don't have a graph on both sides. So this is definitely not even. And because we don't have it on both sides, as in first and third or second and fourth, it's definitely not going to be odd. And there's a special thing about this one because it's a circle. It doesn't even pass the vertical line test. So this one's actually not even a function. So this would be neither. Then looking at our last one, we have, if we find the y-axis, if I draw a line down through here, does that mirror image each side? As in, if this is here, I should have a graph here. And clearly that does not work for this one. So now we're looking at, is this odd? So if I have a graph and I put it here and here, and I flip it upside down, see if it'll let me do that. Does it look the same? It does look the same. Or your last check is pick any point on the graph in the first quadrant. This one's 1, 1. See if you have both signs change, if that point's on the graph as well. So do we have a -1, -1? Yes. Okay. Now I do want to say, I'm always saying pick something in the first quadrant, but it may not have part of the graph in the first quadrant. Sometimes it'll look like this. So if you can't pick something in the first quadrant here, okay, then pick it in the second and make sure it goes to the fourth. Okay. And just like I was talking about before, this distance, okay, an angle should be the same going to the origin as this distance and angle. All right, so there's a few different ways you can think about this. And so that means this one is odd. Definitely recommend looking at a variety of different graphs for this because this can be tricky. I do also want to say, be careful about transformation. So like if a graph is not centered on the origin, then it's not going to be symmetric to the origin. For example, what do I mean by that? So let's say that we have a similar graph like this, but it's like this. Okay, that is not centered at the origin down here. Therefore, it's not going to be odd. It has to be. Like if I pick a point here and I go here, that other point's not even on the graph. All right, so be careful about what may look like an odd function, but that it's shifted some, okay? Those generally are not symmetric to the origin or odd, so just be careful about that.